Okay, this video is going to be the test review that we just did in class. Some people wanted a second look at it on their own, so they asked me to make a video, and I don't mind doing that. So if you feel comfortable doing this, you really don't have to watch this if you feel comfortable with the questions that we did. But if you don't, and it's worth a second look to you, then you can try to follow along what I'm doing, and maybe it'll help you some. All right, but nevertheless, I wish you the best of luck, and I'll see you. Okay, so we're going to look at the first question of this test review. Given that sine of x is equal to 3/4, where x is an obtuse angle, find the values of a cosine of x and b cosine of 2x. Very well. Well, I'm going to take a look at the information they give me. First, they give me the value of sine, which is very handy, and they tell me that x is an obtuse angle. So if I'm doing a test question like this, I'm going to go ahead and sketch the angle. It's kind of what I like to do on an xy axis grid here. So Cartesian coordinate grid, xy. And if it's an obtuse angle, it's going to be somewhere in the second quadrant. So this is going to be something like this. Something greater than 90 but less than 180. Doesn't matter where it is. And I'll call this angle x. There you go. And I can find the sine, the cosine, and all the other trig ratios of x by using the reference angle of this particular x angle, okay? So the reference angle is the shortest distance from the x-axis to the terminal side of that angle. And from this, I can create a right triangle. And since they're telling me that the sine of x is 3/4, I happen to know that this side is 3 and this side is 4 because I'm using this reference angle. So the opposite over the hypotenuse of that reference angle for this right triangle is the sine of x, is what I'm telling you, in other words, which is what they're telling me is 3/4. So what I really need to know is this bottom side right here, which I don't quite know. Well, the deal is, though, I can find it I'm just going to call this P. I usually would call it X, but X is now my angle, as you can see, so I can't use that. So I'm going to call this unknown side P, and I have to find P, which I'll use the Pythagorean theorem for. So I'll say, okay, P squared is equal to 3 squared plus, I'm sorry, that's not true. It's going to equal, let me show it to you in common terms. A squared plus B squared equals C squared is what you're taught, right? So we'll say 3 squared plus p squared is equal to 4 squared. So I just rearrange this equation, and I'll say that p squared is 4 squared minus 3 squared, which is 16 minus 9. So that p will now equal plus or minus the square root of 7, since this is going to equal 7, 16 minus 9. So basically, when you take a square root, it could have two possible values. It would be positive or negative. Okay, those are the possibilities. But in this case, p will be negative because we are to the left of the origin right here. So we're going to the negative x direction. So it's going to be negative root 7. So this is going to tell me that the cosine of this angle will be negative, this cosine of the angle x. Another way of looking at this is this coordinate on the end of this right triangle will have the x coordinate negative root 7 right here, and the y coordinate 3. Obviously, this point in space will have a negative x value and a positive y value. Just think about it like that if you want to. Okay, so let's go ahead and answer the question now. Since we know that cosine of this angle will be the what? It'll be the adjacent side over the hypotenuse, or you can call it x over r is what I tend to refer to it as. We already know this answer. So part A, the cosine of x will equal negative root 7 over 4. And that's your solution, not much to that. Okay, so part B, cosine of 2x. The cosine of 2x is a double angle formula. It's an identity. So the double angle identity, there's three ways you can write the cosine, double angle identity for cosine. So we can write this as cosine squared x minus sine squared x. Or you could write it as 2 cosine squared x minus 1. Or you could write it as 1 minus 2 sine squared x. All of them will actually give you the same value. Okay, so there's some benefits and drawbacks to some of these. The benefit of this one is it's actually quite easy to remember in comparison to the other two for whatever reason, what I've seen in my experience from other students. But the drawback of using the first two formulas is that they have cosine in them, which means you're going to have to use your answer from part A to do this question if you were to use either one of those. If you get part A wrong, that means this question will be wrong if you use either one of those formulas. So you can avoid that pitfall should you actually have gotten part A wrong by using just the last formula right there, which doesn't require a cosine. So technically, though, if you got this correct, which I did here in this question, you could use any three of these and they would all give you the same answer. So just keep that in mind. So I'm actually just going to use the last one just to illustrate that. So here we go. I'm going to say the cosine of 2x is going to equal 1 minus 2 sine squared, right? 1 minus 2 sine squared of x. So this is going to be 1 minus 2. We're going to square sine, and sine they told me in the top of the question is 3/4. So we're going to square 3/4 is what this means. So I'll square the top and the bottom of this fraction. This will give me 9 over 16. I'll distribute that 2. So it's going to be 1 minus 18 over 16. Now, technically, I can turn 1 into any number I want divided by itself. So I can write this as 16 over 16 minus 18 over 16. And now I have a common denominator, which means I can subtract. This is going to give me negative 2 over 16. So when I solve that or reduce it, it's going to give me negative 1 over 8. And this will be my solution, okay? Another thing I could have done is pick another one of these formulas. Let's actually just pick the first one. We could pick cosine squared minus sine squared. I want to illustrate that they're the same answer. So I'll illustrate that they are the same answer by working this out, okay? So I'm going to say, well, cosine squared x minus sine squared x is equal to negative root 7 over 4 squared minus 3/4 squared. Those are my values of cosine and sine respectively. Square the top, square the bottom, right? So I'll get 7. So negative root 7 times negative root 7 is just 7 over 16, 4 squared, minus 9 over 16. This will give me negative 2 over 16, which will give me the same answer, negative 1 over 8. So just to illustrate this point, if you got the question, you could even check your answer using that technique to see if you got question A right, but we did part A right. So I'm just kind of showing you that there's more than one way to get to it, okay? And they're not going to tell you which way to use. You can use whatever way you want, okay? They're just going to grade your work and grade your answer. So just keep that in mind. That's what I'm going to do as well. So that's part A and B for number 1. So we're going to go on to number 2 now. Okay, we're going to look at number 2. The following diagram shows a triangle ABC. The point D lies on the side BC. It's so that the side AD bisects BAC. So it creates two angles that are the same. As you can see, that's what it means to bisect. So we have two angles that are the same right there. Okay, and they tell me that AB is 2 root 5, which is what they gave me right here. And they tell me that AC is X, which they say right here. And basically all this information is there for you. DAC, that angle, of course, is theta. And the sine of theta is 2/3. Now they're going to tell me the area of the triangle ABC is 5 centimeters squared. So find the value of X. So this whole question is asking me to find that value of X in the bottom. Okay, no big deal. And they also tell me, of course, that this triangle ABC, so if I do this ABC all the way to every corner, that entire outside triangle, that area is 5. Okay, so if I know that this area is 5, I can use the formula of the area of a triangle. I can say, well, the area of a triangle, which is 5 in this case, is going to be 1/2 AB sine of C. This is a well-known formula for the area of a triangle. And all this really means, without making it convoluted, is that the sides A and B are just two adjacent sides on this triangle. In this case, my sides will be 2 root 5, and the other side will be X. Those are my A and B, respectively. This angle C is really just the angle in between them. So in the giant triangle here, the big triangle, it's just going to be this angle here, which is double theta. So what I'm really going to say is it's going to be 1/2 times 2 root 5 times X. I'm just plugging in stuff. 1/2, that's A and B. There we are. And then the sine of 2 theta. Since this is the angle we're looking for is this double angle here. That whole corner for the big triangle. So this is a double angle formula, which always happens, right? Now they're injecting some sort of trig identity into what is otherwise a pretty simple question. So we know this double angle formula is for sine 2 theta is 2 sine theta cosine theta. That's the trig identity for the double angle identity for sine. There's only one. That's the only one there is. Whereas cosine, you could write it 3 different ways like we did on question 1. Okay, so we have this one. I'm just going to kind of fill all this out and write it all again and show all my steps, okay? So that's where I am. all this is still equal to 5. Okay, so we got this. So how are we going to go about finding sine and cosine? Well, they have to tell me one of them, and they do. They tell me that sine of theta is 2/3. Now, I can actually pretend, if I want, there's a right triangle here. And that's the sine, that's the angle theta right here. This is the angle theta in the corner. What they're telling me when they say sine of theta is 2/3, this is always a ratio of a right triangle is sine. So they're telling me this opposite side was 2, and this side could be 3. I'm not necessarily saying these sides are the length 2 and the length 3, but the proportion is 2/3. I could actually go further out and say, okay, this could be 4, and this whole thing could be what? This whole thing could be 6. 4 over 6 is still 2/3, so it doesn't really make a difference how long this side is and how long this side is. It just means that the proportion of those two lengths is 2/3. So that's kind of, keep that in mind when I say those things, okay? So let's draw back there. Keep that in mind. So this is what I'm saying. So if I have a right triangle, I'm just going to draw it out here, prevent from confusing people. The sine of theta is 2/3. It's opposite over hypotenuse. So what I'm missing here is this unknown side, which I'm going to call P. I'm calling it P because, again, I'm solving for X, so I usually would call it X, but that's a different quantity right here at the bottom. So to find P, I use the Pythagorean theorem. This is what we always keep doing, right? I'm going to tell you that P squared plus 2 squared is equal to 3 squared. Okay, it's a Pythagorean theorem. So that means that P squared is equal to 3 squared minus 2 squared, and that P is going to equal 9 minus 4, which is 5, or sorry, P squared is going to equal 5, and that means that P will equal the square root of 5. This is going to be positive, the square root of 5, because this angle is acute, and this is like we're saying this is the origin, this is the first quadrant, so this is going to be a positive quantities root 5. So what is cosine in this case? Cosine will be this root 5 over this 3, so that's what this value of cosine is. Pick a darker color so you can see. So let's write this out now. 5 is equal to 1/2 2 root 5 times x. Again, this is the same question we did in class if you were paying attention in the review. And this is going to be 2. What is sine of theta? Sine of theta is actually, they tell me right here, is 2/3. So this is going to be 2 times 2/3. 2 times 2/3. And cosine, I just told you, is going to be root 5 over 3. Let's write that over here. Cosine theta is root 5 over 3. Keep that in mind. And there we go. So we have all of this going on. So all of this set up, and we just have to find x. All we're trying to do is find x. That's the whole premise of all this, okay? So let's actually do that. Let's multiply things out. Okay, if I multiply 2.5, that's just going to be a 1. So you can just pretend like they're not there. It just makes a 1. If I say root 5 times root 5, that's going to be 5. Okay? And we've done those already. So we can just I'm just going to slash them out as I use them. I'm going to say now there's an x here, so let's keep that as 5x. I'm going to multiply these twos together. Okay, this one times the top, which is just going to give me a 4. And I'll multiply the bottoms of these two fractions, which is a 9. 3 times 3 is 9. So my setup now is I have this. I have 5 is equal to 5x times 4/9, pretty much is what I'm doing. Okay, and I'm going to go ahead and multiply across. I'm changing my color still. Multiply this, 5x times the top only. This is going to give me 20x over 9 equals 5. Showing all my algebra steps from algebra 1, I'll multiply both sides by 9, like this. Cross those out, so 20x is equal to 45. Keep changing colors. We'll divide both sides by 20. So divide top and bottom by 5. So this is going to equal 9 over 4. So x will equal 9 over 4. This is the solution for this question. And that's the solution for your answer key. This is how I did it. Your answer key, or the answer key that I'm sharing with you, that we'll share with you, it may not show the solution this way. Their approach may be different, but the fact is the answer is the same. As long as your logic is sound, you can get to the answer from more than one way, of course. So just bear in mind that sometimes when I show you the actual IB solutions to some of these IB questions, they won't look exactly like my solutions, but the answers will be the same, because the logic I'm using is sound, okay? Sometimes they're exactly the same, sometimes they're different. Just keep in mind there's usually more than one way to do a question. So keep that in mind. That's your answer for number 2. We'll move on to number 3. Okay, so Number 3. All right, we got this kind of a quadrilateral looking thing here. That's actually what it is, quadrilateral. And they want me to find BD. It's the first question. BD is this side length here. So I'll find that. Call it BD. And it'll equal something. BD can be found if we use the information from the left triangle that we're looking at. Because the right triangle, the right side, it's not a right triangle, but the right side triangle doesn't have enough information. It only gives me 2 sides. But the left side triangle gives me quite a bit. They give me 2 angles and a side. So if I have a side angle, or something like this, we're going to use the law of sines to solve this. So I will use the law of sines. And the law of sines tells me that any side, like BD for instance, the one I want, over the sine of its opposite angle, so basically over the sine of the angle opposite that, which is sine of 1.75, will equal any other side in the triangle, like 7, over the sine of the angle opposite that, which is 0.82. So we have a setup here, okay? And I want to caution you that these angles are in radians, so make sure your calculator is in radians. I'm going to use the Desmos software to illustrate this. For the kids that don't have calculators, you can actually download the Desmos software for calculations and for graphs. Those are 2 separate apps onto your phone. If you have iOS or Android, it'll work for either one, and they're both free. Okay, so that's what I would prefer you use or ask that you use. If you can't find an app that you like, that's one I would suggest if you don't have a calculator. If you have a calculator, it's all a moot point. But this is what I'm going to do. I'm going to solve this using Desmos, and I'm going to find BD. So to find BD, I'm just going to multiply both sides by sine of 1.75. Kind of like this, sine of 1.75. And these would cross out like this. So BD is equal to what I have here. Okay? So I'm just going to type what I have here in my calculator like this. And I can tell I'm in degree mode because at the bottom here I'm going to toggle between them, as you can see. Notice the answers on the right are all changing if I switch back and forth because I did some trig questions, right? So I'm going to go to radians like this. Okay, so here's what I'm going to do. I'm going to do 7 times sine 1.75. I'm in radian mode. I'll divide this by sine of 0.82. And my answer will be 9.42. That's what it says right there on the right side. And this is basically what I'm using to solve the questions. This is just the Desmos software. 9.42. And this will be in centimeters. Yeah, awesome. So that's part A. And I'll write that here, 9.42. Next question, find the angle DBC. So the angle DBC, this is from D to B to C, is this angle right here. They're asking me for that. That angle. Now, the information I know about this is I have a side, and a side, basically. So what they're telling me I know is that I have a side, triangle. This is what I'm going to have to use on the right side to find that angle. So, of course, whether or not you have a side, or a side angle side, this will be the law of cosines. Those are the 2 situations where you should use this automatically. So the law of cosines, I will keep writing this the same way. This is the only way it appears on the formula chart, as I keep reminding you over and over. All right. And this is going to be a squared is equal to b squared plus c squared minus 2bc cosine of a. Okay. Now you're thinking, well, this is the angle A and it says B right here, right? Well, that doesn't really matter. I can call that A if I want. I can just cross it out. And if I say that, the side opposite angle A will be little a. Just make sure everything's labeled correctly, okay? And I could call this whatever I want. I could call it B right here. And the side opposite that will be little b. And I could call this C. That already is C. And then, of course, this right here, C will be my 9.42. And I just plug it into this formula, technically. But I'm trying to find the angle A. So let's actually solve for the angle A first before we get all excited about plugging in numbers. And what I'll see here is the cosine of A, if I just solve for that, is going to be equal to a squared minus b squared minus c squared over negative 2bc. They actually have this formula written for you also in the formula chart. It's already set up like this. It's really the same equation I just had, and I just rearranged it. But it's already set up for you. Now, to find the angle A itself, since I'm not interested in the angle and cosine of A, I just want the angle, I'm going to get rid of the cosine by taking the cosine inverse of both sides of this equation. That's how I have to get rid of cosine. So turns out A by itself will be equal to cosine inverse of all of this stuff that I have right here. So what goes in here? Well, A squared, I'm telling you A is my 12, so it's going to be 12 squared. B squared, I'm calling it 8, so it's going to be 8 squared. And C is 9.42, which is the answer from the previous question. So again, if you get the previous question wrong, you're about to get this wrong. And IB does that pretty much all the time. 2 and B is going to be 8, and C is going to be 9.42. I can just mash this into a calculator, and I will have my solution. And this will be the answer for this last part, okay? So this is all it is now. Cosine inverse. So I hit function right here at the top that just got underlined. Cosine inverse is right there. I go back to the main, and I'll start putting in the numbers, right? So this is going to be 12 squared minus 8 squared minus 9.42. I'll put that in parentheses and close that, squared. And then I'll actually put that in parentheses. So I have this, and I'll divide. Oh, I don't want that. Be careful here. Make sure that I have enough here. This is really becomes the play of parentheses when you're doing this. Let me see if that'll work. Nope, gives me the same thing. And this is where it can get fun. Actually, I have that right in there if I did that. If I divide there. Okay, that's what I want, like that. So just make sure your parentheses are set up correctly, and this should work out as a nice fraction. And this will be over negative 2 times 8 times 9.42. And then that will be your answer. It's 1.51. And that will be your angle in radians. 1.51. So you have to be careful with those parentheses with that Desmos software. But this is the answer. This is in radians. And that's your solution for this question. This was number 3. So now we're going to go on to number 4. Okay, this is number 4. Question 4 out of 5 questions. And your exam, again, will be a similar link to this review. But here, this is a bearings question. I'm not going to read all this because it's all just basically displayed on the diagram. But when I read bearings, this is a reminder. The bearing 070 degrees means 70 degrees clockwise from north. That's how you read bearings. When I say 115, that's 115 clockwise from north. So this is all kind of displayed in this grid here. So we're just going to answer the questions. They want me to find the angle ABC. So they want me to find this angle right here for question A. And really, there's no quick way to do that. All we're going to really say, the way I'm going to do this is use the properties of geometry. North-south is obviously parallel to north-south, so I can see this. These two lines are parallel. So from the laws of geometry, if those are parallel, this 70-degree angle corresponds to this one. I'm going to say corresponds. They're actually alternate interior angles. Not the same thing as corresponding angles, so I shouldn't use that word. But they're alternate interior angles. 70 degrees is here, 70 degrees is here. So I know this part is 70 degrees, this little angle right here. Also, I know that this entire angle here is 180. Okay? So I already have part of it is 115. So if I take 115 away from 180, this part will be 65. So if I add those together, if I were to say 70 plus 65, that's going to be 135 degrees. So what this now tells me, if I erase all this to make it clean, is that this angle here is 135 degrees right here, which is your answer for part A. And when you start solving the questions, please make sure your calculator is in degrees. I'm going to use the Desmos software to do this. Sometimes I'll use the Inspire, but this time I'll use the Desmos because some of the kids don't have a Inspire calculator. So I kind of want them to see how I would do this on Desmos software, which is free software you can download either for Android or for the iPhone or or iPad or anything else you have, okay, iOS or Android. So please use that if you don't have a calculator. It's one of those many apps you could possibly use. All right, here we go. And it's free. So this next question, what's the distance from town A to town C? That's this next question. So let me get a different color and I'll answer that. This is going to be B. And here's what I know. Let's get a highlighter. I know a side, an angle, and a side. I call that a sassy triangle. Whenever I have a sassy triangle or a side-side-side triangle, either one, this is going to be a law of cosines. This is how you solve these. Law of cosines is what you do when you have one of these two situations. So I am looking for this opposite side here, AC, which I'm going to call A. So I'm going to call that side A, which means this is going to be my angle A. I can rename the angles anything I want, okay? But as long as the side goes opposite the angle, you're good to go. And the reason I'm writing it this way is for a specific reason, because on your formula chart, they're only going to give you one formula for the law of cosines. And technically there's 3 ways you could write it, but I want you to get used to that one formula. And here's what it is. A squared is equal to B squared plus C squared minus 2BC cosine of A. Okay? Realistically, if you're aiming for a 7, you already know how to use that formula without looking at a formula chart. You already know what it is, but let's assume, for now, you're just learning it. And this is what we're going to do. So I'm trying to find the missing side A. This is the opposite angle, capital A. If you want to call this angle C right here, this will be opposite little c right here. And this is angle A, so we'll call this, not A, we'll call this B. I'm changing the name. And we'll call this little b. Remember, I'm doing this angle as A only because this is the only formula they'll give you where that angle is A. This is the only one you get on the actual formula chart. This is why I'm doing that. So here we go. We're going to solve for little a. So this is going to be we're going to take the square root to get little a because it's actually a squared. So let me actually rewrite that. A is going to be the square root of b squared plus c squared, which is 8 squared plus 5 squared. And then minus 2 times 8 times 5 times the cosine of 135 degrees. We actually know the cosine of 135. It's actually negative root 2 over 2 because it's a unit circle angle, if you know your unit circle. However, you do get a calculator, so you don't need to do that. You can just solve this in a calculator. I'm just going to punch this in a calculator, and it'll do the answer for me. It'll give me this answer. So here's my Desmos software to show you can do this question, of course. There's 2 apps for Desmos, one for graphing and one for the scientific calculator. This one, which I've written all over already. And I need to make sure I'm in degrees, okay? And this toggle at the bottom of my screen right here is how you do that. Notice that all the trig questions I've done on the left side, if I toggle, the answers change on the right side. As you can see, that's pretty cool. It's basically giving you all the answers in radians and degrees. It does it automatically for you. Just make sure it says degrees right there. Okay, so now we do this. Square root, right? And this is going to be, so this is going to be 8 squared. 8 squared plus 5 squared minus 2 times 8 times 5 times cosine of 135 in degrees. I hit enter, and it's going to be, of course, 12.0, call it 12.07. So many different decimal answers I've gotten for this so far today, but that's the one I'm going to go with right now. As far as, they're all 12 point something, but if you round or not, depending on the calculator device you use, but that's ballpark about what it should be. And we're going to say use the sine rule to find the angle ACB. This is the last question or the last part of this question. So the angle ACB is this right here. Remember, I'm going from A, which is what they called A. They're calling this C, and they called this B. They called it this B. Right there, as you can see, it was called B. If I can erase that, they called that B initially. So you have to follow what they did. So this is the angle they're looking for that I'm shading, okay? So they're using the law of sines. They tell you that actually use the sine rule. They're being really nice, telling you what to do. what I'll tell you is that whenever you use a law of cosines, you're probably going to use a law of sines somewhere else in a different question. They always like to match those together in the same question. If you use one, you're probably going to use the other. It's not guaranteed, but very, very common. Okay, so here's the deal. The sine of any angle, in this case sine of C, over the opposite side, so we go opposite that side, which is now 5, will equal the sine of any other angle you know. Do I know this angle? For B, yes, so I found that to be 135. That was the answer for the first question. This is going to be the sine of 135 over its opposite side, which I just now found to be 12.07. So here's the deal. If I got B wrong, I'm about to get C wrong. This is what IB does. They're infamous for this. So let's solve this by multiplying both sides by 5, like this, and crossing these out. Okay. And what I'm going to do now is I'm going to solve for this. I'm going to say sine of C is equal to 5, sine of 135. I'll write it all out just for fun. Like this. Now this is going to tell me the sine of C, but I don't want the sine of C. I actually just want C. So I'll get rid of the sine by taking the sine inverse. And crossing that out. Sine inverse of both sides. Like that. So the sine inverse will cross out the sine. All that's left is C, and it's going to equal all of this. So I'll just put this in the calculator again and get my answer. Okay. So I'll go back to my Desmos calculator, and I will do this function right here, where it's got underlined on the bottom. I'll go to my sine inverse, go back to main, which is got underlined there, and then I'll do parentheses. The way I'll type this, 5 times. This is the sine of 135. Close that, divide, so it gives you this nice little division, right? And this will be 12.07. And then I hit enter, and it's going to be 17.03, which will be your solution. This will be in degrees. Okay, so that is the angle right there, is what I'm telling you. So that's your solution for all three of them. This is A, this is B, and this is C. So that's number 4, okay? Now we're on to number 5. Okay, this is number 5. This is the final question of your test review. This is sort of a non-calculator question that you would see on paper 1. Let sine of 100 equal m. Find expressions for each of the following in terms of m. So this right here, we're going to represent A, B, and C in terms of m only. So there's not going to be any trig functions in our answers. So cosine of 100. So here's what we're going to have to relate sine of 100 to cosine of 100. This is not super intuitive, to be honest with you, because there's lots of formulas that relate sine and cosine together. But minus the sum and difference and the cofunction and the double angle stuff, identities, which all involve different angles other than 100. The only one that they really are looking for is the most common one, which is, I'll put this in here, part A. It's going to be sine squared theta plus cosine squared theta equals 1. They want you to use this Pythagorean identity, which is one of the most common identities ever used in trig questions. So what we're going to do here is just say, well, the sine squared of 100 plus the cosine squared of 100 is equal to 1. And I'll subtract sine squared from both sides. So that means that the cosine squared of 100 will equal 1 minus sine squared of 100. And since they tell me the sine of 100 at the top is m, you can think of this as being 1 minus m squared. Sine squared of 100 is sine of 100 times sine of 100. So that's what this means. So since I have a cosine squared of 100 now, and I'm just looking for cosine of 100, I'll take the square root of both sides. So the cosine of 100 will equal the square root of 1 minus m squared. Now this is a trick that a lot of kids, I'm pretty confident, missed. There's a little sign problem here. If you are at 100 degrees, which is kind of like about here-ish, it's kind of narrow here. And this is 100 degrees, we'll call that. You're going to use the reference angle to find all the trig ratios, this reference angle right here, and create a right triangle. But the thing is, what you need to be mindful of is in this quadrant, your x is negative and your y value is positive. So this is going to be a negative x value, positive y value, and your radius is always positive. Since the cosine of that angle theta is always x over r, in this case x would be negative, your cosine is going to be a negative quantity, okay? R is always a positive quantity, so this has to be negative. So don't forget to put a negative sign in front of this. When you take a square root, you get two possible answers, positive or negative. In this case, this quadrant cosine will be negative, so this will be your answer, and just be mindful of that, okay? So that's part A. Part B. This is tangent of 100. Tangent is a quotient of sine over cosine. So tangent of 100 is sine of 100 over cosine of 100. This is very common. All right, sine of 100 told me was m. They told me that at the very beginning of the question. Cosine of 100 I just found. This is negative square root of 1 minus m squared. That negative on the bottom, I can move it to the top if I were so inclined. This is the same thing. And then I would just leave my answer like that. And I wouldn't try to rationalize it. This is going to be this, okay? Not much to it, really. If you know what you're doing, this question doesn't take very long, actually. And the last one, part C. Sine of 200. This is a double angle formula. So sine of 200 is actually 2 times the sine of 100 times the cosine of 100. If you're not sure what I just did there, I use this formula. Sine of 2 theta is equal to 2 sine theta cosine theta. This is the double angle formula for sine. So now I know how to do this. I know they told me that sine of 100 is m. Again, that's the very beginning of the question. And this is the answer for part A. This is going to be negative the square root of 1 minus m squared. All of this just gets multiplied together. And this is going to be negative 2m square root. That doesn't look good. 2 times m, negative 2m, square root of 1 minus m squared. And this will be the solution, okay? So those are all three your answers, A, B, and C. And that's how you do this question. Hopefully that makes sense to you. I appreciate you watching this. I wish you the best of luck, and I'll see you around.